Hi everyone. As Sean, as João say, my name is Igor, and I am psychologist. My background is study about ADHD with sample about cohort in Brazil. The high risk cohort in Brazil. It's a very famous cohort here, and I finished my master 2 weeks ago. So I defend my thesis, and right now I try to start my PhD. So this is my actually my status as a professional. So today I'd like to share with you a brief idea about cluster analysis and how it can be useful in the data analysis process. So first, I want to apologize because this presentation was supposed to be last week, and I had some personal issues, and I couldn't attend this agenda. So, thank you so much, João, for filling the schedule. So, and today I bring some topics, and I like to present first of all an introduction to the concept of cluster and some history aspects, and second, methods of similarity and why they are important in a cluster analysis pipeline. And thirdly, some application examples, and finally, a brief hands-on session with a summarized pipeline. So in this hands-on, I just screen printed my screen and share because I think it's more practical. So uh, about cluster for me, one of definition it's makes sense for me about cluster. It's cluster is a task aimed at adjusting a series of observations into the same group based on some similarity criterion. So similarity criterion is an important definition here when we speak about clusters. So there are several types of cluster analysis, and today my focus is more on the use k-means. I will explain more shortly. So I decided to focus on these methods, but the time and it's very shortly. So um, okay, so I start with a brief history. The early records of cluster analysis usage come from two anthropologists, so it's very curious, and who were interested in similarities between cultures based on a series of common indicators among them. And after this, uh, uh, we saw the cluster, improvement in your methods and apply in other areas, and started subsequently, the method was further explored in Psychologist by Joseph Zubin and Robert Tryon, and finished by Cattell. I think Cattell is the most famous for applying the cluster in his methods about personality traits. So here it's a basic, some, for me, the most important events in the cluster history. So about similar methods in cluster analysis are like a fundamental for group data, so that the items within each other or cluster are more similar to each other than to items in the other group. So I like to talk more about two types of similarity because it's most used, like Euclidean distance and Manhattan distance. The term, when I say distance, is like just way of measuring similarity. So that mean uh, by is that for me using distance methods, what is close is similar. So it's like a definition about similarity. So what is close, it's similar. So there are other applications case where the density methods the density methods might be more appropriate. So for example, use it new urban plane context. So based on the assumption that similar means close, I will discuss the two methods, Euclidean and Manhattan distance. So first of all, uh, Euclidean distance maybe perhaps is the most known and widely used metric. So it measures the direct distance between 2 points in a multidimensional space by calculating the square root of the sum of the squares. So that's the whole definition about the math into the Euclidean method. So uh, okay, the sum of the squares and the difference between the corresponding coordinates of the points. So where x and y are feature vectors of the objectives being compared, and n in the formula is the number of features. So in the context of k-means, which I will explain more detail shortly, Euclidean distance used to calculate the proximity between data points and the cluster centroids. Centroids like a point, it's a in the middle of the other points. So the algorithm assign each point to the cluster whose centroid is closest and minimize the variance within each cluster. And on the other hand, the Manhattan distance, also known as L1 norm, is calculated the distance between 2 points by sum the absolute difference between the coordinates. And both of these methods used in situations of the Manhattan methods is useful in situations where absolute difference between coordinated are more relevant than square difference. So but although less common, the Euclidean distance in traditional k-means, Manhattan distance can be preferred in contexts where the data have outliers or high variance, or where the coordinates represent measures on different scales. So that should not be squared. So in k-means usage, the choice between Euclidean or Manhattan distance is very significant because can significantly impact in the result. So Euclidean distance tends to form more spherical clusters due its natural and while Manhattan distance can result in cluster with more rectangular or elongated shapes. I will show you more about this for you. So the appropriate metric choice depends on the nature of the data and the analysis objective. So depends of your questions about your data. So for high dimensional data or data with varied scales, Euclidean distance might be more appropriated. For data with outliers or when greater sensitive to absolute difference is desired, maybe Manhattan distance could be the right choice. And for just keep just go on, I will speak about k-means. And k-means, it's a supervised learn algorithm using to cluster a data set into k clusters. So the goal of k-mean is to partition the data so that the points within each cluster are more similar to each other than 2 points in the other cluster. So that's an important definition here. So the algorithm follows basically some steps. So we start in initialization. You choose the k initial centroids, which can be selected randomly. And the second step is cluster assignment. Assign each data point to nearest centroid, form a k cluster. And three, it's a calculated centroid. So it's the calculated the position of the centroids and that mean of the points assigned to each cluster. So and finally you repeat this. The algorithm will repeat these steps until found the number of centroids or the position of the cluster. It's the optimal position. So when we speak about k-means, the history behind the k-means initially introduced by Stuart Lloyd in 19 1957 during his research at Bell Labs, and however, the algorithm was not widely known until it was rediscovered and published by J. McQueen in 1967. So since then, the k-means has become of the most popular clustering algorithm due to its simplicity and efficiency. So here I show you some strengths of k-means. So first of all, simplicity. So k-means it's easy to understand and implement, and its steps are intuitive and can be quickly executed, so make it accessible even for beginners. So the two strength is the efficiency. The algorithm is computationally efficient, so especially with large data sets, so it's good use it k-means. Scalability, because can be easily scaled to large data sets, as I said, and flexibility. So it can be used in various domains, from custom segmentation in marketing to image compressions and pattern detection in biomedical data. So is a lot of areas you can use it. So some weakness is because first of all you need to predefine the number of clusters. So maybe this is like a hard choice. You need to choose a better technique to select the optimal number of k, and and sometimes involves experimentations and cross validation, and this maybe can be hard. So sensitive to initial position, so the choice of initial centroids can significantly influence the final result. Different ones can produce in different clusters as well, so especially if the initial centroids are selected randomly. So, and the cluster shape, it's other weaknesses, like the mean assumes that clusters are spherical and are similar size, and that's a problem because this can lead to inadequate cluster when clusters have irregular shapes or size, like when the outliers and noise is the other weakness, because it's very very sensitive to outliers, and outliers data point can distort the centroids and affect the cluster quality. I will show you more shortly the effect of the outliers in a cluster analysis. So here we have some uh, application examples. So for example, using or potentially comings like image recognition, as you see, is like the cars and the bike. So in image recognitions, k-means use it to compare features extracted from the image, and such as feature vectors or color histograms, and try to identify the similarity between query image and the image in a database. Like you you will use k-means and calculated the distance between the features vectors on the image, and the image with the smallest distance is considered the most similar. Like when you try to compare the vectors, and the smallest distance is like a similar. And customer clustering in marketing, so it's very used today. Like company use k-means to group customers based on their purchasing behavior and the demographic data, and the application it's more common. Each customer is represented by a feature vector, like selected age, income, purchase frequency, use the platform, and you try to use k-means and try to find the distance, and selected some groups, enable target markets campaigns, and just like uh, gold client, silver client, as Amazon use a lot these commands for this, for example. And recommendation systems is very used in the stream and e-commerce platforms, and you use k-means to recommend products or content based on your pattern used in platform, like uh, try to find the similarity between users of items, like for example, Netflix movie, similar to those the user has already watched, are recommended based on the distance, the sometimes Euclidean distance between the features of the movies. Other example here, I remember I saw some examples using by performance of athletes. For example, in sports, the k-means can be used to analyze athletes' performance by comparing metrics such speed, endurance, and accuracy. So, like you use the vector of the values, and you can compare or try to group some individuals based on your your abilities, your skills. So, and maybe it's help the coach can identify players with similar performance levels and try to put together in the same match, for example. The other example, as I you know it's a like treatment response pattern identification. So identify response pattern to treatments, like you some meds, so subjects who respond similarity and those who do not, like and what they have in common when just use some med and try to understand the response after using the med. So like we use a data set to try to calculate this. So I will show you now an example. Is a like a shortly hands-on. Here I created a fake data set, and this data set we will use it. Uh, is a problem. A problem here, a fake problem here, is could be defined as a Brazilian health manager needing to identify similar profiles of hospitalization rates based on income, for example. So the idea is to redistribute resource to try to improve health indicators. So I started question can be it is possible to identify similar cities profile based on hospitalization rate and average income. So this is a question here, and we try to resolve this question use cluster analysis, use k-means. So as you can see here, these values are from seats that represent my state. So it's a real seat, but the numbers is fake. So, but here we have some variables like seat, population, hospitalization rate, average income, human development index, proportions of doctors, and proportions of psychologists. So the data set has this dimension. So first step in cluster analysis after the preprocess the data is to scale the variables in the same scale. So here I show you, I just import the data set and use some libraries in R. And after this, I selected just three columns to show the example here. I selected the city variable, the tax hospitalization variable, and the average income. And here I start with Z-score. I scale my data set because it's like a assumption to run a cluster analysis. So I just used the standard function in R, scale, and remember I just just cut the town variable here because it's not like a continuous variable. So as I mentioned, of the problems with k-means is that we need to set the number of clusters. So here to number cluster, I use a method. I think it's more common in psychology. So we use a lot this method. It's like a script plot or able method. And when you try to found the k optimus number of the the cluster. So we try to understand more how much cluster I need to set my algorithm. So it's very common use uh, this method. So I will use a graph to visualize the able break, like you can see here. And this function comes from the factor extra, the function f vis nb cluster. And I am using the dataset without the seed column, as I say, and I specify which cluster method I will use it. I select k-means, and the method WSS is a metric uh, that means within cluster sum of squares. So this method calculates the sum of variance within each cluster and sum then for the whole cluster. And the idea is to find a point where adding more cluster does not significantly reduce the variance within the cluster. So this indicating the optimal number of clusters. So after define the number of clusters, as you can see here, maybe 3 is a good number. And now I configure the algorithm by specifying the number of clusters and the number of times I want to be executed to identify the best possible convergence. So here I define 3, the number of clusters, and I start with 50 iterations. So next I use the fvis function to check the cluster plot, and this line code created a visualizations of the cluster formed by the k-mean analysis. So as you can see here, 3 clusters, maybe it's a good division, like each point is like a city, and the 3 clusters separate the cities based on income and the rate of the tax of the rate of hospitalization. So maybe if I try to understand more about profiles, these cities based on 2 indicators, maybe clusters show me the first step. So it is important to see the points on the graph, and as I say, represent the cities, and the convex ellipses are drawn around each cluster to show the boundaries. So I define convex as I methods, but maybe I can try other method like norm. But for norm, I need to the assumption of the distribution of the data. So and here, as you can see here, we can consider the outliers. So when we have outliers, the cluster, it's like weird here. So it's not cool. The and you know. So what is the metric we can available? We can measure the fit of the cluster. So to check this, we can use the many methods as well, but that can be used to check, how well the clusters fit the data, and here I use the silhouette indicator, so which ranges from -1 to 1, and this scores measures the cohesion and separations of the clusters, provide an indication of how well the data points fit into the respective clusters. So, uh, so 0.32 is like is not a perfect fit, but when most neighbor to 1, it's better. And when we consider the fake data and the fake situation, it's like maybe it's a good fit. But in summary, this line of codes here calculates the silhouette scores for each data point in the k-means analysis results, and the silhouette scores provides a measure of the quality and the classification of each point in this cluster. So consider the cohesion within the clusters and the separations between clusters. So silhouette values, as I say, have a range, and here the range is maybe good when we consider the fake data, but that's it. Did some reference. I hope I hope you can you understand well as I say. So that's it. Thank you.
Thank you, Igor, very much. I it's cool when we get people to present about their work because we always learn a little bit things. I haven't ever seen the silhouette plot before, so that's an interesting approach to that. Um, so in the concept of the silhouette, that seems like a goodness to fit indicator that is specific for class membership, if I'm not mistaken. So
Um,
and
yeah,
of course, if you don't know the answer, that's fine. We can all read and learn more about it. But the concept there, from what I understand, is a class membership is attributed to each participant. And then is that kind of like an entropy? Is that a measure of how what is the error of the class membership?
I think it's more about the how good it's the division of clusters. I don't know if I can explain this now, but uh, it's similar to like when you try to use some metrics in machine learning, for example, F-score, for example. So the model is a good fit, but in cluster, it's most common use silhouetted method.
João, you're muted.
It looks interesting. I have to read a little bit more than to grasp the concept. Thanks for introducing that. The other question that I had is when 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 using the when using the silo when using the k-means overall to do predictions, is the approach to use the class membership as a prediction of a given outcome? So we're kind of predicting which class membership somebody will be.
Uh, it's a k-means. It can use in the two situations, to classification and regression models. Like, but I don't know if I understand well your question. It's about the used k-means in the classification or regression models. That's it, João.
Yeah, that's what I'm trying to, because usually when I think about clustering and k-means, I think about it as an unsupervised task that you're trying to find the classes and then trying to find how one is likely to be in one of those classes. But I've seen people use it as part of a pipeline to do a supervised task. And then in that sense, is it a two-step process where you find the class membership and then use the class membership as a predictor to the classifier?
Yeah. For me, I use it k-means more like middle step. You know, it's not like the finish model. Like it's just to when I don't have questions about my data set and when try to explore the data set, I just try to use k-means to found some insights, found some questions like. Uh, 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 in the few years ago, I used it in a project about how can divide the neighborhoods in the capital using the metrics about the COVID. So, death about the COVID-19. So, like, how can I understand the distribution of the death based on income, based on the population? So like this is more like explore method than like a finish method for me. Just I and after used k-means, I try to use all the method clusters like LCA, latent class analysis. So it's like a second step after you use k-means, and it's like try to find the latent structure between the clusters. So that's interesting. So complex, but very interesting.
And
Yeah, that makes sense.
do you, Igor, I haven't worked much with unsupervised techniques. Do you have some sort of uncertainty on the classification? Like, is it like your output, like you did the cluster for your fake data as you showed us? Let's say for a given municipality there, the cluster wasn't so sure that this municipality was actually for belong to cluster number one, but it may be, with some uncertainty could be cluster number two. Can you get that some sort of a confidence interval or some confidence, all of those classifications?
This is I think this is a problem in Camins because sometimes the distance it's so close and the algorithm has some difficulties to cut off, like just divide here, and this is a problem, and it depends of your data, it depends of your question. So it's because of this I have some I have some concern about use it just Camins to as a finished model, as a unique model in the data set, because this problem is very, very common in this situation. But I think if you just try to understand more about the data set, like for example, currently I work on in a project about the response treatment. So I try to understand about which variables it's most important to response the treatment about ADHD. So I just put these variables in the same k-means, in the same models, and I try to understand the patterns of response. Like some
Okay.
people respond in a way, the other group respond in the different way. So I use it for this, and I can understand more. So if I found like the same point or very similar point, I just try to use other methods or like this. So yes, it's a problem in Camins, and it's uncertain, as you say.
Okay. Thank you.
Yeah, I like this method a lot. I think at one meeting we should probably try to bring in a paper that talks about the criticisms that clustering has received, because I think it's something that I know epidemiologists don't like it very much. I personally enjoy it a lot. I like the idea of using k-means to try to grapple some of the issues of confounding, even as a step in between for other kinds of modeling. Um, but it's a great entry to the conversation. We've used it in several projects at Gemini, and I think it's a very interesting approach in that sense. And thanks for the codes. If you have those codes somewhere that you could share so that we can start kind of assembling a little template, that would be great.
Of
Otherwise, I
course,
think it's a good entry. Anybody
yes.
have other questions?
I just
Go
say
ahead, Igor.
one thing I forgot to say. It's very similar to factor analysis, it's like is very similar because it's the same family of the tests, but factor analysis uses the variables. So a group the variables in the structure latent in latent structure, but the cluster use observations, use lines. So it's different because that's the that's a small difference, but it's very important to understand. Uh, 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 I forgot to say this, but yeah.
Yeah, I like it. There's one step before doing factor analysis or doing clustering that I think we could talk about at one meeting, which is the decomposition process, where we kind of create the decomposition matrix to find the separation, right? And that I think once we discuss the decomposition I think it becomes easier for people to understand that they can apply the methods that find patterns by distances. So I agree with you 100%. I do want to mention, I love one thing you said where I like it very much when we break down the method to the concept. And then once you break the method to the concept, then there you understand that there is a particular task you can use the method for, and then there's multiple methods that answer the same task. And I really like when you start the presentation saying clustering is an approach to try to find similarity between data. And especially when you talk about now in comparison to factor analysis, which is a similarity between people or observations, and so I'll say people, versus a similarity between variables or indicators. Because I think it creates this notion that there's a family of arguments, that a family of methods that look into similarity, and then we can break them down based on what kind of data and what kind of task they are answering, which is very different than other kinds of methods. So I really enjoyed that explanation as well. So thank you, Igor. Cool. Any other questions? Okay. No, if no other questions, thank you, Igor, very much. We got this recording. If you could share the presentation.